Hello. So today we discuss the divide and conquer strategy. Okay. So in divide and conquer, so by using the divide and conquer, we have to solve the problem. So the problem will be giving us in a big problem, big size problem. So at first we divide the problem into the many small sub problems. Okay. And then recursively solve the sub problems and then combine the solutions of the sub problems and then create the final solutions. So that is the divide and conquer strategy. So at first, in the base case, solve the problem directly if it's smaller enough. So then divide the problem into two or more similar and smaller sub problems that I said in the previous, and then recursively solves the whole the sub problems, and then combine the solutions to the sub problems, and then create the final solutions. So now we discuss the sorting techniques. Okay. So under the sorting technique, the base case, divide recursively and combine. These four methods will be declared in here. Okay. So here are two shots, mass shot and quick shot, that are defining in this class. So what is the mass shot? Mass shot means 10 or 20 or 30 data will be giving to you in the question paper. At first we have to divide in two parts. The whole problem is divided in the two parts. Okay. Or otherwise I'm explaining in a very basic way. So 20 values are giving onto you. Okay. So at first 20 is divided 10 or 10 in two parts. Then one 10 part is divided 5 or 5, and another 10 part is divided 5 on 5. Then each sub problems, that means 5 or 5 or 5 or 5, so are dividing in another sub problems. Then I'm just arranging in ascending order and then create the final solutions and then merge all the solutions. So that is the merge shot. So here is the merge shot example. I'm just giving the 8 values, and that I said in the previous way, I'm just dividing in the two parts, left part or right part. Okay. So at first I'm checking just the first element. Okay. That means k equals to 0, I equals to 0, j equals to 0. Then I'm checking the second part, I equals to 0, j equals to 1. Then k equals to 2, that means I'm checking the third part, then fourth part, and then here we go, the fifth part, and so on. Okay. So here is the algorithm of the merge shot. So at first merge a left, middle, right, then n1 tends to middle, that means a left plus 1, or right tends to the middle. So then creating the array, a left array and a right array, and then I'm using the for loop. So the value of the I will be defining by using 0 to n1 minus 1, or do li equals to a left plus I, and then I'm using the for loop of j tends to 0, and to n2 minus 1 do rj, so a middle plus j, and then using the for loop of k. So k tends to I, tends to j, tends to 0, that means the value of the k will be 0. So then I'm using the while loop, so checking the value of I, and if I is less than n1 and j less than n2, Then I'm using the if statement. So if li less than rj, so ak plus plus tends to li plus plus. Otherwise, else ak plus plus tends to rj plus plus. Then I'm using another while loop. So the checking the value of I. So I is less than n1, then ak plus plus tends to li plus plus. And also using another while loop for the j, while j is less than n2, then ak plus plus tends to rj plus plus. So n equals to n1 plus n2 and the space equals to n. And here is used also the time, so cn for the some constants c. So here is the another example of the merge sort. So 8 values are taken in this problem. So the whole problem is divided into two parts. That means 4 or 4 that I said in the previous slide, and then 4 is divided into 1 2, and then 2 is divided into 1 or 1. Okay. So here is the graph. The n is divided n by 2 or n by 2, then n by 2 also divided n by 4, and then 2 2 dot dot 2. Okay, so total running time is big theta of n log n, or the total space big theta of n. So here is the divide and conquer strategy. So most of the work is in the merging, and the total time of big theta of n log n and the space complexity will be big theta of n. So more spaces than other shots. So now we discuss the quick shot. So quick shot is another type of divide and conquer strategy. So here is we divide the whole problem and then recursively sort the first part and then second part and then combine the whole problems, or combine the whole solutions of the sub problems and then combine the all solutions and to create for the final solutions. Okay. So in quick shot, in the divide part, pick any element P as the pivot element. So example, the first element will be pivot, and then partition the remaining elements into the first part, that means in the left side, and the second part, that means on the right side. Okay. So then recursively sort the first part and second part and then combine. So no work is necessary since sorting is done in the place. Okay. So in this slide, I'm showing just the details of the first slide. Here is the algorithm of the quick shot. So quick shot in a left right, if left greater than equals to right return, then else middle tends to partition of a left right, and quick shot a left middle minus a 1, and quick shot a middle plus 1 right, end if. Okay, so I'm just giving the value of 8 elements. So 4 is the first element, okay, and then I equals to 0, that means I is defined by the 0, and then j equals to 1. Okay, then 6 j equals to 2, then 8 j equals to 3, and then 5 j equals to 4, then 1 j equals to 5, then j equals to 6, then j equals to 7, and then completed. Then the value of the I in the previous slide, when we jump 3 to 1, then the value of I will be 2. Okay, and after completing the process, then I the value of the I will be 3. Okay, so now i'm I'm just taking the 4 in pivot element. Okay, so pivot in the correct positions. So is the partition algorithm of quick sort. So partition A, left right, x tends to a left, I tends to left, and for j tends to left plus 1, I'm using the for loop. For j tends to left plus 1 to right, and if aj less than x, then I tends to I plus 1. Then we use the swap. So swap ai or aj. So end if, then the ending the for loop of j, and then another swap ai, a left, return I. So n equals to right minus left plus 1, so times cn for the some constant c, and the space will be constant. So in quick shot, I'm just taking 8 elements. Okay, then at first we have to choose the pivot element. Okay, the pivot element will be choose from any side, right or left. Okay, after choosing the pivot element, then we have to compare with the pivot element and with the other elements. Okay, the pivot element is compared with the other elements, and that means if the value of the left side is less than the pivot element, then it will be swap. Okay, and then check the right side element with the pivot element is greater than of the pivot element, then it will be swap. Okay, and under this, and that this procedure will be continue for completing the whole procedure. Okay, so at first I'm just dividing in a two parts. Okay, then finding the pivot elements and then compare all the elements that are present in the left side or right side with the pivot element, and then after completing the whole procedure, then I'm just combine the whole solutions. So that is the quick shot technique. So here is the example of quick shot portion. Okay, this is a quick shot based case. The n tends to cn, n is divided n by 2 or n by 2, just like mass shot, then n by 4, and then 3 3. Okay, so total time big theta of n log n. So here is the average case of quick shot that is defined in this slide. So quick shot summary, the time complexity. So most of the work done in quick shot by partitioning technique. So average case of big theta of n log n time, and the worst case takes big theta of n squared times. And then the space complexity. So shots in place, that is does not require any additional space. So there is no space complexity in the quick shot. Okay. So in the divide conquer part, we we were discussing the mass shot, then quick shot. Okay, so most of the work done in merging on log n time or on space, and then quick shot. So most of the work done in partitioning, average case big O of n log n, and the worst case takes on squared time and o1 space. So now we are discussing the searching technique. So in searching technique, given a file of n records, n the number of problems with the ith record. So 1 less than equals to I less than equals to n, so consisting of a key field that containing in the integer si, and the several other data fields that containing the information. Okay, so I'm just discussing the binary search. So RAM binary search. So it's the algorithm of RAM binary search, SXK. So step one, at first we have to check the value of I. That means I tends to 1, then h tends to n, then k tends to 0. So step 2, we are using the while loop. So I equals to, sorry, greater I equals to h. Okay, so then m tends to I plus h by 2. If x tends to x equals to sm, then I k tends to m, or I tends to h plus 1. And then just in this way I'm completing the binary search. Okay, so time complexity of binary search big O of n log n. Okay, so now I'm discussing the parallel binary search. So in the parallel binary search, there are n processors, and we can extend the binary search to become an n plus one way search. So binary search algorithm consists the many stages. So each and every stage, the sequence of the numbers that's still in the consideration. So that divided into the n plus one subsequence of equal length. Why subsequence? Because it's a divide and conquer strategy. So I'm just dividing the whole problem in a many sub problems. So the n processor tests the elements at the boundary between the adjacent subsequences for the quality with x, and s is assumed to be sorted from left to right in the non-decreasing order. So here is the algorithm of the parallel binary search. So at first we have to check the value of q, r, k, g. Then we are using the while loop and then for loop. The value of I and j will be defined by using the for loop and then if statement or else statement, and then completing the parallel binary search procedure. The time complexity of parallel binary search will be big O of log n n.